Hello everyone, and welcome to this model on raster and vectorial analysis for renewable energy planning. This is part of our online course on geospatial tools in the energy sector, designed specifically for master students. In this video, we'll do two main things. First, we will learn the difference between raster and vector data and why this is important in the energy context. Second, we will learn how to download wind resource data from Global Wind Atlas, which we will then use throughout the rest of the module. So let's start with the first part of this module. Raster versus vector. What is the difference between the two? First, we need to clarify what we mean by raster and by vector. These are the two fundamental types of geospatial data, and each one has specific strengths and applications. Raster data is like an image. It's a grid made of cells and pixels, and each cell contains a value. This value could be temperature, it could be elevation, or in our case it is wind speed. The higher the resolution, the more detailed the raster, but also the larger is the file. For example, if we look at global wind data, every pixel might represent the average wind speed at that exact point over 1 year. So it's an average over the time. Could be also 1 month, for example. Raster data is continuous. It changes smoothly over the space and is often used for things like satellite imagery, elevation models, solar radiance, and wind potential. In contrast, vector data is made of discrete geometries, so points, lines, and polygons. Points can represent things like meteorological stations, lines might be roads, power lines, and there could be also borders of countries or regions. Polygons are used to define areas like countries, land parcels, or protected zones. So in our project, we will use raster data to describe wind availability and vector data to define the constraints such as country borders or exclude areas like national parks. Now we will explore the Global Wind Atlas. Now that we know what raster and vector data are, let's look at how to get high-resolution wind data. One of the most accessible sources is the Global Wind Atlas, developed by the DTU in Denmark in collaboration with the World Bank. It offers a lot of free capabilities, is well documented and easy to use. So please go ahead, open your browser and visit the website. On the left of the screen, you will see a global map with the wind speed patterns at different hub heights. This is at like 50 meters, 100 meters, 150 or 200 meters, and you can select in between these heights. These heights refer to the height above the ground where the wind speeder is measured. This is very relevant for wind turbines with a huge impact on potential energy yields. So the higher the hub height, the greater the wind speed, as there's less influence of obstacles and there are, for example, no disturbances by houses or trees. You can use your mouse to zoom into a specific region, for example. Let's focus on Europe and Italy in particular. Now we will need to download the wind raster data from the Global Wind Atlas. So go to the Download Data section, look at the top right corner of the page, and there's a small download icon. Click on that and navigate to the section GIS files and MPI access. Now you need to select the following features: the country, for example Italy. Then you need to select a layer, which is wind speed, and here it will provide the main wind speed. And then finally you need to select the hub height. So we will choose 100 meters in our case, which is the standard for wind turbine analysis. The file format is a GeoTIFF. That's the raster file compatible with QGIS. So click on download, save the file somewhere where you can easily find it, and maybe in a folder called GIS course or wind analysis project. Make sure you have enough space on your computer for the file, and the download also take some time, especially when you are analyzing larger regions. Now we will need to prepare the files for the next step. So once the download is completed, it's a good habit to quickly check the metadata. So inside the zip or next to the TIFF file, you usually find a TXT or XML file that explains the projection, the units, and how the data was generated. This is especially important if you are comparing datasets from different sources. You always want to make sure that the coordinate reference system matches. So in our case, the Global Wind Atlas uses EPSG 4326, which is the VGS 84 geographic coordinate system. We'll talk more about that in the next video when we load the data into QGIS. So to recap, we now understand the difference between raster and vector data. We've downloaded wind speed data in GeoTIFF format from the Global Wind Atlas. And we are ready to open QGIS and start exploring and processing the data. In the next video, we load the raster file into QGIS, add country borders as a vector layer, and perform a clip operation to limit our data to a specific country or region. See you there.